Hello dear students, so welcome to Wallah channel, and in this lecture, in this one shot, we will be covering the second part of the signal and its type. We have already studied the type of elementary, analog and discrete signals. We have done the integration and summation of the delta functions. Here we will be solving and we will be studying the very important the type of signals and the basic operation on signals. I am Siddharth Sabharwal, rank 1 GATE 2021, rank 3 Engineering Services 2015 and MTech from IIT Delhi. These are the topics that we will be covering today: basic operation on signals, periodic signals, energy power signals, even odd signals, and conjugate symmetric, conjugate anti-symmetric signals. Okay, so let's start the class. Let's start the class with the basic operation on signals. So basic operation on signals, we have three basic operations, that is time shifting, time scaling and time reversal. Okay, and these are very important. These are very important basic operations that we will be studying today. Okay, now let's start. Just a moment. Okay, so first of all, we'll see time shifting. A very simple and basic operation, and the technique by which I'll be explaining here, time shifting. In this technique, you don't need to remember that when it is right shift or when it is left shift. Okay, so suppose we have a signal. We have xt as a signal. We have xt as a signal, and we create yt is equal to xt plus 3. So randomly I have taken this. So xt is a signal that I already have, and I create a new signal that is yt. And yt is equals to xt plus 3. Okay. Now, so how to see that the signal is shifted right or left? So there is a very simple technique, that is put t equal to 0. Put t equal to 0 in this equation. We will get y0 is equals to x3. That is the value of the signal at t equal to 3 in the old signal is going to 0 in the new signal. I am repeating the statement, and this is very important for judging. That is, the signal that is t equal to 3 in the old signal is going to t equal to 0 in the new signal. Or we can say that 3 is jumping to 0. 3 jump to 0. So if 3 is jumping to 0, it means left shift by 3 units. Okay, this means this operation is left shift by 3 units. Okay, left shift by 3 units. So let us take an example here. For example, I have a signal. -4 to 7. This is a signal that is xt. Okay, na? This is a signal which is from -4 to 7 xt. And now if I want to create xt plus 3, so always remember that the new signal 0 is equal to old signal 3. So 3 is jumping to 0, means it is left shifted by 3. It is left shifted by 3. So left shifted by 3 means the 7 will go to, left shift by 3 means 7 will go to 4 and minus 4 will go to minus 7. So left shift by 3, and this is what is xt plus 3. Okay, and this is xt plus 3. I hope all of you are able to do it. This signal is xt plus 3. This signal is xt plus 3. The height will remain the same. For example, height here is a. Here also the height will be a only. Okay, height will be a only. So this is what it is. Okay, so you can always put t equal to 0 whenever you want to see the what is the amount of shifting, time shift. Simply put t equal to 0, you will get that it is right shift or left shift and by what amount. Okay. Similarly, one more example. For example, this yt is equals to x of t minus 6. Simply put t equal to 0. Simply put t equal to 0 here. So y0 is equal to x of minus 6. So here we can see that minus 6 in the old signal is jumping to 0. So minus 6 is jumping to 0. Minus 6 jumping to 0 means forward movement or right shifting by 6 unit. Minus 6 jumping to 0 means right shift by 6 units. Okay, right shift by 6 units. This is what it is. Okay, so any example? We can take any example. Suppose we have a signal which is minus 4 to 3. Height is a. This is your signal xt. So what will be xt minus 6? Xt minus 6 means right shift by xt minus 6 is right shift by 6 units. So right shift by 6 means 3 will go to 12. 3 will go to 12. 3 will go to 9. Right shift by 6 units. 3 will go to 9. Minus 4 will go to 2. And height will remain same, that is a. Height will remain same, that is a. So you don't need to remember that when it is right shift or when it is left shift. Simply put t equal to 0 and you will get the answer. That simply put t equal to 0, you will get that minus 6 in the old signal is going to 0. So minus 6 going to 0 means jumping right. Similarly here, 3 is going to 0 means jumping left. 3 is going to 0 means jumping left. So I hope these points are clear to all of you. No one is having any kind of doubt in this whole scenario. Okay, great. So this is shifting operation. So here also there are some examples for more clarity. We can see y0 is equals to x2 means 2 is going to 0. 2 is going to 0 means left shift by left shift by 2. Okay. Now next example. This one. y0 equals to x of minus 3. y0 equals to x of minus 3 means minus 3 is going to 0. So since minus 3 is going to 0 means it is right shift by 3. Right shift by 3. Okay. Same exactly similar manner we have the discrete cases. There is no difference in the analysis. We can easily get the result from here also. That is y0 is equals to x of 5. That is 5 is going to 0 means left shift by 5. Okay, left shift by 5. Okay, left shift by 5. Similarly, here we can see that y0 is equal to x of minus 4. So minus 4 is jumping to 0. So in the old signal, minus 4 is jumping to 0 location. Minus 4 jumping to 0 means right shift. Okay, I hope all of you are able to do this, students. Right shift by. So this is all very simple things. You just have to put t equals to 0 or n equal to 0 and get the complete result very easily. Okay, you don't have to remember. Now, after shifting operation, there is another operation, that is time scaling. So, time scaling means we are compressing the signal or expanding the signal. There are two things in a scaling operation. In a scaling operation, we have two things, that is compressing and expansion. There are two things only, expansion and compression. Okay, now let us see what is happening here in these two options. There are two options only, there are two examples. So let's see what is happening in this example. So what is the example? So this is what it is given to us. So again we will do the analysis by putting t equal to 0, t equal to 1, t equal to 2, and we'll get the result. So first of all, we'll put t equal to 0, we get that y0 equals to x0. So 0 goes to 0 means 0 is not changing the location, and since 0 is not changing the location, we can say that there is no shifting. Since 0 is not changing the location, there is no shifting. There is no shifting, and since there is no shifting operation, let's put t equal to 1 now. So t equal to 1 means y1 is equals to x of 2. So 2 is going to 1. That is, in the old signal, the location 2 is going to 1 in the new signal. Okay. Similarly, we put t equal to 2. So y2 is equals to x of 4. In the old signal, t equal to 4 is going to 2 in the new signal. So what is happening here? We can see that since 0 is not changing the location, so there is no, since 0 is not changing the location, there is no shifting. But 2 is going to 1, 4 is going to 2. Thus, we can say that the whole signal is contracting. The whole signal is contracting. So, here is an example for it. Suppose we have a triangular signal which is from minus 10 to 10 and height is 20. Height is 20. Thus, now this is your xt signal. This is your xt signal. Okay. Now we need x of 2t. So since 0 is not changing the location, 0 is same in both the signals. 0 is not changing the location, but only the whole signal is getting contracted. The whole signal is getting contracted. The new signal will be something like this. It will contract. So this will be from minus 5 to 5 only. And height remains the same, that is 10. Height remains the same. Only the it get contracted rather and the shape remains the same. Shape remains the same, only the signal gets contracted. Okay, so this is your x of 2t, it is getting contracted, it is not getting shifted. Okay, now, so always remember this kind of operation. Since 0 is not changing the location, it is not getting shifted. Okay, only 2 is going to 1, 4 is going to 2. Since thus, we can say that it is getting contracted. Now, next example, yt equals to x of t by 2. So, let us take an example for this. Yt equals to x of t by 2. So in this case also, we can see that y0 equals to x0. Okay, just put t equal to 0 here. So there is no shifting. There is no shifting. 0 is 0 are same. Now put t equal to 1. T equal to 1. So y1 is equals to x of half, means in the old signal, whatever was there at 0.5, it is going to 1. Okay. So 0.5 is going to 1. Similarly, y2 is equals to x of 1. That is, whatever is there at t equal to 1, whatever is there at t equal to 1 is going to 2. Is going to 2. And so on. So we can say that 1.5 is jumping to 1. 1 is jumping to 2. So it is getting expanded. The whole signal is getting expanded. Okay, is this clear to all of you? All of you are able to do this? I hope all of you are able to do this point. This point is clear to all of you. Okay, now suppose we have a triangle from minus 10 to 10. Okay, so it will get expanded from minus 20 to t. So minus 10 to 10, let us say the height is 20. Okay, this is your xt. Okay, this is your xt. Now the shape will not change, only it will get expanded. Shape will not change, only it will get expanded. Only it will get expanded. So shape will remain the same, the height will remain the same. Only it will get expanded. It will go from minus 20 to 20. I hope all of you are able to do this. Okay. So this is your xt and the bottom one is x of t by 2. Okay. I hope all of you are able to do this. Great. So here also we can see that 0 location is not changing. 0 is y0 equals to x0. Thus there is no shifting. Only we can see that y0 equals to x0 means no shifting. There is no shifting. But y1 is equal to x3. y1 equals to x3 means 3 is going to 1. 3 is going to 1 means it is contracting, compressing. So this signal, we can say that x of 3t is compressed version of xt. Is compressed version of xt. Okay, x3t is compressed version of xt. Similarly, in this example, this one, we can see that y0 equal to x0, but y1 is equals to x of 1 by 3. So x of 1 by 3 means 1 by 3 in the previous signal, in the original signal is going to 1. So we can see that it is getting expanded. X of t by 3 is expanded version. Expanded version of xt. I hope all of you are able to do this. These points are clear to all of you. Great. But there is something different in case of discrete. Whenever scaling, whenever shifting is done, so discrete and continuous shifting are almost same process. But in case of discrete, scaling is a little different from the continuous domain. So how it is different? Let's see one example. Let me explain you the scaling operation in case of discrete. Okay. So this is the figure. This is our xn given to us. Okay, xn is given to us. 0, 1, 2, 3, 4, and yn is equals to x of 2n. Yn is equals to x of 2n. So we can see that yn is equals to x of 2n. Okay. So here we can see that y0 is equals to x0. There is no shifting. There is no shifting operation. Here we have no shifting operation. Y1 is equal to x2. Y1 is equal to x2. So we can see that we have lost one sample. Okay, y1 is equals to x2, y2 equals to x4. Okay, so we can see that we are getting only even number of samples. We are getting a zero sample, we are getting zero sample is going to yn. We are getting the second sample x2. Okay, now then we are getting the fourth sample. We are getting the fourth sample. Okay, so we are missing the odd samples. We are missing the first sample, we are missing the third sample, and so on. So we can see that if we see your yn, so yn at 0, yn is equal to x of 0. Okay, yn is equal to x of 0, that is 5. Now y1 is equal to x of 2. X of 2 is equal to 2. y2 is equals to x of 4. Okay. Similarly, y of minus 1, we can see that y of minus 1 equals to x of minus 2. This one. It is 2. Y of minus 2 is equals to x of minus 4. So x of minus 4 is 0. So we are getting 0. So here we can see that it is very important to observe, please. It is very important to observe. Thus we can see that in case of yn is equals to x of 2n, okay, we will take only the even samples of xn. Okay, at 0 location we will get x0, at n equal to 1 we will get x2, at n equal to 2 we will get x4, and so on. Similarly, we will get x of minus 2 and so on. Okay, so this is how we will get the signals. We will get the signal yn. Similarly, if yn is equals to x of 3n, then yn will be, so what will be the 0 location? At 0 we will get 0, x0 only. But at n equal to 1, y1 is equals to x of 3. X of 6 and so on. Similarly, so this is what it is. This is your yn. Okay. So I hope all of you are able to understand this, that here we are losing the samples. In this case, yn, if we have yn, we have lost the sample x1 and x2. We have lost the samples x4, x5. We have lost the samples in this case. Similarly, here also in this process, we have lost the sample x1, we have lost x3, we have lost x5, and so on. So, in this process, we can say that we are losing the samples of xn. We are losing the samples of xn, and this process is called downsampling, or it is sometimes called decimation. It is sometimes called decimation. Okay. Okay. So here we are losing some information. Okay. Information is lost. loss of information in this process. Okay, loss of information in this whole process. I hope all of you are able to get this point. Great. Great. Next, now here we can see the other problem, that is yn equals to x of n by 2. Okay, so this is what it is. We can see that y0 equals to x0, y1 equals to x of 1 by 2. Now what is x of 1 by 2? We know that it is a discrete signal. In discrete signal, the term inside the bracket has to be integer only. So x of 1 by 2 will be 0. So y1 is 0. y2 is equals to x of 2 by 2, that is x of 2. x of 2 by 2, that is x of 1. y3 will be 0. y4 will be x of 4 by 2, that is 2, and so on. So we can see that so here we can see that that output yn, the signal yn has all the samples of xn. Okay, we can see that that yn has all the samples. Yn has x0, yn has x1, yn has x2. Only we are placing 0 between the two samples. Okay, only we are placing the 0 between the two samples. For example, in this case, if I draw yn, so at 0 is going to 0. Okay, y0 is equals to x0, so 0 is directly going to 0. 0 is directly going to 0, so this is your 5. Okay, but y1 is equal to 0, so we added a 0 value between two samples. Okay, between two samples we added a 0. Now y2 is equals to x1, so y2 is equal to x1. So at two location we have the value that is equal to x1. What is x1? x1 is 4. Okay, then y3 is equal to 0. y3 is equals to 0. Then what is y4? y4 is equals to x2. So 2 goes to that 4 location. So if you observe this, you will get that this is -1, -2, -3 and -4. So similarly we can see that y of -1 will be 0, because y of -1 will be x of -1 by 2, x of -1 by 2 will be 0. So y of -1 will be 0. Y of -2 will be x of -1, that is again 4. Okay, that is again 4. Y of -3 will be 0, because y of -3 will be x of -3 by 2, that is again 0. And y of -4 will be equal to x of -2, that is 2. So if we look at yn image or yn figure, we can see that the yn figure is exactly similar to xn figure. It has all the samples, only we are adding 1 0 location, 1 0 between the two samples. We are adding 1 0 between the two samples. Okay, so we are adding 1 0 between the two samples. So we can see that yn equals to x of n by 2, yn is equals to x of n by 2 here, yn equals to x of n by 2 here. Yn is exactly similar to xn, only we add 1 0 between the two samples of xn. Okay, we add 1 0 between the two samples of xn. Okay, simply we add zeros. This is called zero padding. This is called zero padding. Okay, we pad 1 0 between the two samples of xn. We pad 1 0 between the two samples of xn. Okay, between the two samples of xn. Okay, great. All of you are able to see this? Great. Similarly, just remember, always remember that yn equals to x of n by 3. In case of yn equals to x of n by 3, yn will be same as xn. Yn will be same as xn. Only we pad two zeros between the samples of xn. Yn is same as xn. Only we pad two zeros between the samples of xn. So we have one more example here for more clarity. So this is your signal xn. We need x of n by 3. So at 0 location we will get this only. At 0 location we will get this only. Then we add two zeros. Then we add two zeros. Then we add this sample. The next sample is 4. Then we add two zeros. Then we add the next sample, that is 2. Okay. Similarly, we add two zeros. We add the next sample, that is 4. We add two zeros. Then we add the next sample, that is. So this is your yn. This is your yn, that is x of n by 3. Okay. Great. So always remember that in this process there is no information loss. We simply add, we add zeros. We add zeros. One more thing. This process is called interpolation. Okay. Okay. So this is the whole thing. Simply remember this final result. This is the general result, that is, in case of yn equal to x of n by m, in case of yn equal to x of n by m, we add m minus 1 zeros between the two samples of xn. Okay, this is called interpolation. I hope all of you are able to understand this. Okay, great. So let me conclude here. How many of you are feeling sleepy? 20 minutes into the online classes and continuously watching 8 episodes on TV series. This is the comparison. I hope all of you are very awake, all of you are very alert. So conclusion is this. Conclusion is yn is equal to x of mn, where m is any constant, m is any integer, m is any constant, where m is any constant, okay. So when m is any constant, then this process is called decimation. Okay, here we have data loss, and here we take the samples which are at the multiple of m location. For example, y0 equals to x0, y1 equal to xm, y2 equals to x of 2m. So we take 0th sample, then we take mth sample, then we take 2mth sample in case of xn. Okay, for creating yn from xn. And the second one is the process that we have already seen, the summary also, that is x of n by m. So we add m minus 1 zeros between the samples of xn. Between two samples of xn, there is no data loss. There is no data loss. There is no data loss, and this process is called interpolation. This process is called interpolation. So I hope all of you are able to understand these processes. Now let's come on to the last point, that is time reversal. Time reversal means, for example, yt equals to x of minus t. Yt equals to x of minus t. This means, that y0 equals to x0. There is no shifting. There is no shifting here. We can see that y1 is equal to x of minus 1. So what was in the previous signal at minus 1, it goes to 1. It is going to 1. Okay. Similarly, y2 equals to x of minus 2. What was at minus 2 location, it is going to 2 in the new signal. So we can see that the new signal is simply obtained by flipping this signal about this vertical axis, or by taking the mirror image of this signal with respect to the vertical axis. So by taking the mirror image with respect to the vertical axis. Okay, so if we take the mirror image, we will get like this. This is minus 5. And this is 4. Okay, height remains the same, that is height is 10. Okay, so we simply flip it, or we take the mirror image with respect to the vertical axis. We take the mirror image with respect to vertical axis, or we simply flip it. We simply flip it. Okay, so this is what the figure is. So in case of time reversal, it is the same process. In case of continuous or in discrete domain, simply flip. Simply take the mirror image with respect to the vertical axis. Okay, with respect to the vertical axis. So I hope all of you will be able to do this. No issues in this. Okay. Similarly, in this case also, we will simply flip it and we'll get the time reversal. We'll get the time reversal. Now, here we have a very important result. Here we have a very important result, and this result will be used in case of time systems also. When we will talk about the type of systems, there also we will be discussing the whole concept, and the concept is that the time reversal, time scaling and time shifting, these systems work on variable t only. Variable t only. They work on variable t or n only. They work on variable t or n only. So what is the meaning of this? Right shift by 3. Now recall from the discussion that we have already done that right shifting by 3 means, if input is xt, then the output is right shift by 3 means x of t minus 3, right? So xt will convert into x of t minus 3, that is right shifting. Great. So we can see that the system is replacing, t by t minus 3. System is replacing t variable by t minus 3. So if the input is x of minus 4t plus 7, then the result will be, always remember that the system work on variable t only. So this will be minus 4 t minus 3 plus 7. Okay. So always remember that you will only replace variable t with t minus 3. So when the input is xt, then the result is x of t minus 3. when the input is cos of 4t plus 7, then the result will be 4t minus 3 plus 7. ठीक है ना? Cos of 4t minus 3 plus 7. Okay? Great. Understood everyone? Now compression by 2. Compression by 2 means if xt is given, then the signal is x of 2t, the output signal, that is compressed version. So this is compression. Xt gives x of 2t. So we can see that the system replaces t by 2t. The system replaces t by 2t. Okay. So always remember that the system will work only on variable t. So here we can see that x of 3t will convert into x of 6t plus 9. Variable t will convert into 2t. Okay. Now xt will convert into x of 2t. And the third one, cos of minus 2t plus 6 will convert into, we'll replace t by 2t. Okay. So always remember that these systems work only on variable t. They work only on variable t. Similarly, time reversal, when xt is the input, then time reversal is x of minus t. That is, it replaces t by minus t. It replaces t by minus t. Okay. So x of minus 3t plus 4, it will replace t by minus t, that is output will be x of 3t plus 4. Input is xt, then the result will be x of minus t. And when the input is x of cos of 4t plus 9, then the result will be minus 4t plus 9. So I hope all of you are able to do this. Great. Okay. So now let's continue with the type of signals, that is periodic and non-periodic signals. So now let's move on to periodic and non-periodic signals. Okay. This is a very important classification of signals, because many questions are asked from this domain, from this topic. Okay. So first of all, let us see the definition of periodic, non-periodic signals. So definition is very basic and there are two parts of definition. Any signal which repeat itself after a finite duration of time is called the periodic signal. And the second very important characteristic is the periodic signal must exist on the time axis for the time range minus infinity to infinity, or minus infinity to infinity on the n-axis. So it is very important that the signal should exist on the time axis or n-axis for the infinite, that is from minus infinity to infinity, then only it is periodic. Okay. And first thing is, any signal which repeats itself after a finite duration of time is called periodic signal. Okay. Now there is one more definition part. Let us see. What is the part that the definition part? One more point is there. For continuous time signal, For continuous time signal, the definition is xt is equals to x of t plus t naught. That is, if you shift the signal by t naught, capital T naught, then you will get the same signal again. Then, that is, if we shift the signal by t naught, if we shift the signal by t naught duration, then we will get the original signal. So, this is the definition of we will get the original signal. Okay, and thus this is the definition of the period. This T naught is called the period if it is satisfying this equation. If it is satisfying this equation. T naught is called period of the signal if it satisfies the above equation. Okay, if it satisfies the above equation. Okay. Similarly, and here there is no condition on T naught. There is no condition on T naught. T naught can have any real value, any real value. It can be rational, it can be irrational, it can have any value. But for the discrete time, the equation is almost similar. Xn plus n naught. Here n naught is the period. N naught is the period. N naught is the period of the signal. Okay. But the same condition that is written above, that is, if you shift the signal by n naught time and you will get you are getting the same signal back, then n naught is the period, and the condition is n naught should be integer. Okay, n naught should be integer. Great. Now let's move on. These are the two very important equations for the periodic signal, and the condition on n naught is it should be integer. Now let's talk about the basic periodic signals of continuous domain as well as for the discrete domain. So first of all, let's talk about for the continuous domain. For continuous time, okay. Now there are three basic signals. There are three basic signals, that is complex exponential, cos and sine. So for continuous time, there are three type of signals, that is e to power j omega t, cos omega t, and sine omega t. Always remember that these are periodic signal. These are periodic signals, and they are periodic with period 2 pi by omega. Always remember that e to power j omega t, cos omega t, and sine omega t, these three are periodic signals, and they are periodic with period 2 pi by omega. Always remember this. Okay. Now we talk about the discrete signals, discrete time domain. Okay. Now how we are getting this period? Just I'll try to explain one example. Okay. One example for you. What is that example? Let's see. Okay. So how we are getting this period? So there is very simple explanation for that. we know that cos of 2 pi plus theta is equals to cos theta, right? Cos of 2 pi plus theta is equals to cos theta. Or we can say that cos of 2n pi, where n can be any integer, plus theta equal to cos theta. Now, if we want to find out the period of, if xt is cos omega t, then xt is cos omega t, then we have to find the period of it. Period of xt. So, period of xt is equals to x of t plus t naught. Okay. So, we will use this equation here, that is cos omega t is equal to cos omega t plus t naught, that is okay, this. Now we can see that these two will be equal to each other. These two will be equal to each other when this omega t naught is equal to 2n pi. Okay, if we compare it with this equation, we can see that these two terms will be equal to each other only when omega t naught is equals to 2n pi. Now, since t naught has to be minimum value, because period has to be the smallest shift that satisfies this equation. T naught is the smallest shift that satisfies this equation. So, we will put small n is equal to 1. Small n is equal to 1. We will get T naught is equals to 2 pi by omega. So, this time period 2 pi by omega is for cos omega t, sin omega t and e to power j omega t. Always remember that in continuous time domain, these three signals are always periodic and they have the period 2 pi by omega. Now we talk about the discrete signals. Now we talk about the discrete signals. Now here we have a very important condition, as well as let's see the period of it. Okay, so let's take any example and from there we will derive the result. For example, any signal xn is equal to cos omega naught n. Okay, any signal xn is equals to cos omega naught n. So let the period is n naught. Okay, let the period is n naught, capital N naught. So what is the condition for periodicity? Xn is equals to x of plus n naught. Okay, so okay, now so we can see that cos of omega naught n is equal to cos of omega naught n plus omega naught n naught. Okay, now using the same condition that we have used in the previous slide, that is this one. So we can say that this term, we can say that omega naught n naught is equal to 2n pi. Okay, omega naught n naught is equals to 2n pi, where n is an integer, n naught is an integer. Okay, now here we have a very important condition. So here, from here we can see that n naught upon small n is equal to 2 pi by omega. Okay, so we can see that on the left hand side we have n naught upon small n, where capital N naught has to be integer because period is always integer in discrete case, and small n is also integer. But on the right hand side we have pi, that is an irrational number. So the condition is The condition is this omega naught should have a pi term so that pi and pi are cancelled, and then only RHS and LHS can be equal to each other. Okay, so the condition is I'll write that condition here because it is very important condition. It is very important condition. So what is the condition? The condition is cos omega naught n is periodic only when omega naught has a pi term. Omega naught has a pi term in it. Okay, omega naught has a pi term because then only that pi term will cancel. Okay, and n naught will be this left hand side, that is integer upon integer, can be equated to integer upon integer only. So cos omega naught is periodic only when omega naught has a pi term. Pi term means omega naught is of the nature 7 pi by 18, 5 pi by 7, anything, but it should have a pi term. Okay, pi term in it. Okay, if omega naught has a pi term, then period n naught is equal to 2 pi n upon omega. Now how to find the period? I'll show that with the help of example. Okay, so I'm writing a conclusion statement here. I'm writing a concluding statement here. So in case of continuous time, cos omega naught t, sin omega naught t. Now I want all of you to reply cos omega naught t, sin omega naught t, e to power j omega naught. Are they always periodic? Yes, these are always periodic. Remember that these are always periodic. They are always periodic with the period 2 pi by omega naught. But in case of discrete time, that is, the signal is cos omega naught n, sin omega naught n, and e to power j omega naught n. These will be periodic only when omega naught has a pi term in itself. Okay, these are not always periodic. These are periodic only when if omega naught has a pi term in it. Okay, na? And if it is periodic, then the period is 2 pi by omega naught multiplied by n. Okay, and the condition is n naught has to be integer. This is an integer. Okay, this is an integer. Okay, great. Now let's move on. Let's see few examples. So question number 1, find out the period of e to power j 5t sin 20t for cos 2n. Let me write all the questions, then we will solve it. Okay, so let's solve all these questions. So first of all, e to power j 5t, it is a continuous time domain signal. It is always periodic, and the period is 2 pi by omega naught. What is omega naught? Omega naught is 5. So the period is 2 pi by 5. Okay. Second, here we have sin 20t. Here also we can see that the period t naught is 2 pi by 20. Okay, 2 pi by 20. Third one, cos 2n. It is discrete signal, and thus we can see that discrete signal omega naught does not have a pi term. It does not have a pi term, so it is non-periodic. Okay, it is non-periodic. Now this one, here also we can see that this omega naught, this term does not have a pi term, so this is also non-periodic. Okay, and the last one, now we can see that this omega naught has a pi term. Yes, omega naught is 5 pi by 7, so it has a pi term. It is periodic, and how to find the period? So this is periodic, and how to find the period? The period n naught is 2 pi by omega naught into n. Okay, n, small n. So what is the use of this n? I'll tell you here only. So let's put omega naught here. We'll get n naught is equals to, omega naught is 5 pi by 7, so we'll get 14 pi by 14 by 5n. Now we know that n naught is an integer, and it is 14 by 5 into small n. So for making n naught integer, we will put the smallest value of n. So here we can see that we will put small n is equal to 5. So that 5 and 5 will cancel, and n naught will be the smallest integer, that is 14 in this case. So put n as the smallest integer, smallest, so that n naught is an integer number. Okay, so we can see that n naught will become 14 here. Okay, one more example for more clarity. Are you able to see this? 14 by 5, we need to make it an integer, so we'll multiply it by 5. Simple. Okay, so one more example. Sixth is sine of 2 pi by 9. Take another 4 pi by 9. Okay, so here we can see that omega naught has a pi term, and thus period will be okay, this will be the period. So here we can see that this will come out to be 9n by 2. So what should be the minimum value of n? What should be the minimum value of small n so that this term become an integer? Obviously 2. So 2, and we'll put n is equal to 2 for getting n naught as the smallest integer, that is 9. Okay, so this is how you are going to do these kind of questions. Now we have one format of the question which is very favorite to the GATE exam, that is we have combination of signals. Combination of signals means sum of signals. So we have a signal that is a capital XT is equals to x1t plus x2t plus x3t and so on. There are many other time domain signals which are added, or we have capital Xn okay, this is what we are getting. Now we are given, so we have capital XT signal which is a sum of many other small time domain signals. We have capital Xn which is a sum of other time domain signals, x1n, x2n, x3n and so on. Now we have to find out what is the period of this signal. So our motive is to find out whether capital XT or capital XN is periodic or not. Okay, this is our motive. Okay. Now, just one more thing, one thing which is very important for analysis, that is, if we have a periodic signal, if you have a periodic signal and you add a DC value to it, you add a DC value to it. Okay, for example, you have a sinusoid, you add a DC value 1 to it, then in that case the period does not change. Always remember that adding a DC value, for example, we multiply a periodic signal by any constant value, then also it will remain the same period. Period does not change. So adding a DC value, subtracting a DC value, multiplying a DC value and dividing a DC value to a periodic signal will not change the period of the signal. Okay? Adding, subtracting, multiplication, multiplying or divide of any periodic signal with a DC will not change the period of the DC signal. ठीक है ना, ऐड करो, सब्ट्रैक्ट करो, मल्टीप्लाई, डिवाइड of any periodic signal with DC, not change the period of the signal. Not changes period. Okay, I need more space. Add, subtract, multiply, divide. Of periodic signal with DC does not change its period. Okay, great. So now we have to solve this. Again, I am repeating what is the problem statement. The problem statement is these are the signals which are added to create a new signal, capital XT. These are the signals which are added to create a new signal, that is capital XN. Okay, we have to find out the period, that these are two periodic or non-periodic. Okay, this is what the problem is. So what is the method to solve it? There are few steps that we will follow. Method, that is step number 1. Step number 1 is, if any of this individual signal is DC, we can remove it from the analysis. Remove any DC signal from the analysis. Okay, remove any DC signal from the analysis if there is any, and find out the period of all the signals. Find out the period of all the individual signals. Find the period of all the individual signals. Okay? Find the period of all the individual signals. Great. If any of the signal is non-periodic, if any of the individual signal is non-periodic, if you find out that any of this signal is non-periodic, then the overall signal will be non-periodic. Any signal is non-periodic, then the overall signal capital XT or capital XN will be non-periodic. Okay, if any of the individual signal is non-periodic, then the overall signal will also be non-periodic. Okay. Now this is step number 1. Now step number 2. Find the period of all signals. That we have already done. Okay. So let the period of x1t is t1, x2t is t2, x3t is t3, and so on. Okay. So just we are taking the numbers like x1t has a period t1, x2t has a period t2, x3t has a period t3, and so on. Similarly, x1n has a period x1, x2n has a period n2, x3n has a period n3, and so on. Now you have to find out the ratios in this step. What are the ratios that you have to find out? Now in this step, we have to find out the ratios. Find out the ratio, that is T1 upon T2, T1 upon T3, T1 upon T4. Similarly, find out the ratios N1 upon N2, N1 upon N3, N1 upon N4, and so on. Okay, generally not more than 3 signals are there in any exam, in any question. Okay, so just find out the ratios, that is T1 upon T2, T1 upon T3, and so on, N1 upon N2, N1 upon N3, and so on. If any of the ratio is not integer upon integer, if any ratio is not integer upon integer ratio, if any ratio is not integer upon integer ratio, then the complete signal capital XT will be non-periodic. Okay. Why we have not written the condition here for xn, capital Xn? Because in case of the discrete signal, these n1, n2, n3 are always integers. So these ratios will always be integers. So this condition is only for this, the continuous time domain signal. For discrete time domain signal, this condition does not exist, because for discrete time, the period ratios n1 upon n2, n1 upon n3, n1 upon n4, they are always integer upon integer, because the periods are always integer. Okay. So this condition is only for the continuous time domain signals. Okay. Now let's move on. After this step, okay, so let me repeat the step. The step is we will find the ratios T1 upon T2, T1 upon T3, T1 upon T4. If any of the ratio is not integer upon integer, then whole signal capital XT is non-periodic. Okay. Now step number 3, I'll write here itself. If all ratios are integer upon integer, then are integer upon integer, then find the LCM of all denominators. ठीक है ना? If all the ratios are integer upon integer type, then find the LCM of all the denominators. Okay, all the LCM of the denominators. So find out the denominators of the ratio. Take the LCM of the denominators. Let the LCM is equal to alpha. Let the value of the LCM is equal to alpha. Then the period will be T naught, that is period of xt will be equal to alpha times of n1 alpha times of t1. Okay, the period of xt will be alpha times of t1, and similarly n naught, that is period of xn, will be alpha times of n1. Okay, will be alpha times of n1. Okay, great. So this is the whole method. Just recall all the steps. Step number 1 is find out the period of the signal. If any one is non-periodic, the whole signal is non-periodic. Step 2, find out the ratios T1 upon T2, T1 upon T3, T1 upon T4, N1 upon N2, N1 upon N3, N1 upon N4. If any of the ratio is not integer upon integer, then complete signal is non-periodic. This condition is only for xt, okay, not for xn. And the last one is all the ratios having denominators, okay. So find out the LCM of all the denominators. Let the LCM is alpha. So the complete period will be alpha T1 or alpha N1. This is the whole method. Let's see a few examples for more clarity. For example, xt is equals to sin 20t plus cos 10t. Okay. So yes, both the individual signals are periodic. Yes, this is always periodic. This is always periodic. Now let us find out the period. Let's take one more example. One more from here. E to power j 15t. Okay. Now, so this is also always periodic. The t1 is 2 pi by 20. This is always periodic, 2 pi by 10, and this is always periodic. T3 is equal to 2 pi by 15. Okay. Now we have to find the ratios. Okay. All three are periodic. Now we have to find out the ratios. T1 upon T2 is directly we can see that T1 upon T2, that is 2 pi by 20 divided by 2 pi by 10. This will be 1 by 2. Now T1 upon T3 is equals to 2 pi by 10 divided by 2 pi by 15, that is 15 by 20. This is 3 by 4. Okay, 3 by 4. Now we can see that we have two denominators, that is 2 and 4. What is the LCM? LCM of 2 and 4 is equal to 4. Okay. So the period of the signal will be T0 will be 4 times of T1, that is 2 pi by, we can see that multiplied by 4, 2 pi by 5. Okay, I hope all of you are able to do it. Great. One more thing which is very important and many times it is asked, the fundamental frequency of the signal. The fundamental frequency of the signal. So what is the fundamental frequency of a signal? Fundamental frequency of a signal is 2 pi by time period. 2 pi by time period. 2 pi by n naught. Okay. Great. So this is the period of the signal. I hope all of you are able to do it. Let's see one more example for clarity. For example, xt is equal to okay, so this is a signal. So we know that all these are always periodic. So these signals are always periodic. T1 is 2 pi by 2 and T2 is 2 pi by 4 pi. Okay. Now here we can see that T1 is equal to pi and T2 is equal to 1 by 2. Now it is very easily visible that T1 upon T2 will not be an integer upon integer ratio. T1 upon T2 will not be integer upon integer ratio because it will have an irrational number, that is pi, and thus the whole signal is non-periodic. Okay, so we can see that this is a non-periodic signal. I hope all of you are able to do it. Yes, I hope all of you are able to do it. Great. Now, one more example. For example, xn is equals to 5 cos of 2n. Now, it is very easily visible that these two signals are non-periodic, because discrete signal is periodic only when the omega naught has a pi term in it. There is no pi term here, and since there is no pi term, thus we can say that this is non-periodic, this is also non-periodic, thus the overall signal is non-periodic. The overall signal is non-periodic. Okay. One more example. Now let me use another page for it. Okay. So one more example. Five pi n by 7. Okay, so these are the three signals. These three are discrete signals, and we can easily get the answer. That is, this is periodic. And how to find out the period? We know that period n1 is equal to 2 pi by omega naught. What is omega naught? Omega naught is 2 pi by 7 n. So we can see that it is 7n. So we can see that n1 is equal to 7. n1 is equal to 7. n2 is equals to 2 pi upon 4 pi by 9 n. So this is 9n by 2. This is your n2, and here we can see that for minimum integer value of n2, we have to put small n is equal to 2. So n2 is equal to 9. Third, n3, we can see that it is 5 pi by 7. So period is 2 pi 5 pi by 7 n. So this will cancel out and it will become 14 n by 5 n3. So we can see that n3 is equal to 14. Okay. So n1 we have, n2 we have, n3 we have. Now we have to find out the ratios and then the result. So n1 upon n2 is 7 by 9. n1 upon n3 is equal to 7 by 14. That is 1 by 2. Now the ratios or the LCM of the denominator, we have two denominators 9 and 2. What is the LCM? LCM of 9 and 2 is equal to 18. 18. And thus the final result, the period n0 is equal to LCM multiplied by n1. That is 18 into, okay, 18 into 7. So what is 18 into 7? 18 into 7, 7, 8, 56, 7, 1, 2, 7, that is 120. Great. I hope all of you are able to do it. Great. This is how we have to solve the problems of periodic and non-periodic signals that you can easily do. Now, there is one more concept, that is, shifting of the signal, time shifting of the signal of the periodic signal. Suppose we have any periodic signal and we are shifting it. We are shifting it on the time axis. Now shifting it on the time axis will not change its period. So shifting of the periodic signal does not change the period. Does not change its period. Okay. Similarly, inversion, time inversion will also not change its period. Okay. Time reversal. Time reversal also does not change the period. Okay. And we know that addition of DC also does not change the period. So here we can see that this is time shifting and adding DC. Time shifting and adding DC does not change the period. The answer is 24 only. Here we can see that we are subtracting a DC, it will not affect. Shifting does not affect, but here it is very important to observe that x of 2t means the signal is getting contracted. Now when the signal will get contracted, the period will become half. So the period will be 12. Okay. Similarly, time shifting does not affect, multiplying by DC does not affect. Only this time scaling will affect. Time scaling means we are compressing it by 3 factor. So the period will become 24 by 3, that is 8. Okay. Now shifting, time shifting does not affect, multiplying by DC does not affect, x of 40. So here we can see that it is getting contracted by factor 4, that is 6. 6 is the new period. So I think these are the concepts that can be helpful in any exam. In any question we can keep these concepts. Okay, one more concept that was left in time shifting is this. Yeah. Suppose we have to get this signal. This is very, very important. I just forgot to take. From xt we need to create, suppose we need to create x of minus 3t plus 12. Okay. So from xt signal we need to create this signal. Okay, suppose. So we can see that there is a shifting, there is a scaling factor, and there is a time reversal factor. So always remember that we have to apply the operation in this format. First of all, apply time shift. Always remember the sequence. First of all, we have to apply time shifting. Then we have to apply time scaling. And third, we will apply the time reversal. Okay, then we have to apply the time reversal. Okay, now let's solve it. We can see that we have to shift it by 12, right or left. So let's see. Suppose this xt is there, xt we give it to a box and we get at the output that is x plus 12. Okay, we need this. So it is right shift or left shift. Thus, just remember it. It is left shift. Okay, just recall it. We have already studied it. So it is left shift by 12. Okay. Now, if we see this signal and we again give it in another box. So what is this another box? Another box is time scaling. Time scaling compressing by factor 3. Compressed by 3. So compressed by 3 means we will get, and we know that these systems always operate only on variable t. So this will be x of 3t plus 12. And finally, we have to apply the time reversal. We have to apply the time reversal. Time reversal. So this will simply replace t by minus t. So always remember the sequence, and this sequence is very, very important. Okay. So let's continue with the next classification, and which is very important, that is energy and power signals. So another classification is energy and power signal. Okay. So we have three type of signals, that is energy signal, power signal, and neither energy nor power signal. Three type of signal: energy signal, power signal, and neither energy nor power signal. Okay. So the question format is how to find out the type of signal. Okay. The first is neither energy nor power. Always remember that if any signal touches infinity, any signal is having value infinity, then it will be a neither energy nor power always. Okay. Second, power signal. Power signal can be only of two types. There are two things in power signals. There are only two type of power signals. That is, one is having constant amplitude for infinite duration, and second one is periodic signal. So periodic signals are always power signals. Remember that. And next is energy signal. Energy signal are of two types. That is signal having finite amplitude for finite time duration first. Second is signal is of infinite duration, but it is of decaying in nature. It is decaying in nature. So this is the formula for energy signal. That is, the energy of a signal is minus infinity to infinity mod of xn whole square summation minus infinity to infinity mod of xt whole square dt. This is the energy. So if any signal is having finite energy, it is called energy signal. Okay, and there are only two possibilities for energy signal, that is any finite duration signal with finite amplitude, any signal of infinite duration with decaying in nature is this. So we have one example here. So e to power minus at ut, where a is positive. Okay, so this is the curve e to power minus at ut, and since there is ut, so it will start from t equal to 0. So to find out the energy, we will take the square of this signal and integrate it from 0 to infinity. Why we are integrating from 0 to infinity? Because the signal is starting from t equal to 0. And next is the energy of some standard signal. This is the standard signal. Let us say this is a rectangular signal from minus tau to tau. So energy of this will be height square multiplied by width. Height square multiplied by width, a square multiplied by 2 tau. Now let us see one more example of triangular function. Okay, triangular function. So triangular function is like this. So this is a triangle from minus tau to tau. Height is a, let us say. So energy of this signal is equal to a square multiplied by width divided by 3. Okay, a square, that is height square multiplied by width divided by 3. This is valid for all triangular signals. Any triangular signal, you can apply this formula and you will get the energy of that signal. So here we can see that it is a square into 2 tau by 3. Okay, a square into 2 tau by 3. I hope all of you are able to get this. Great. Let's move on. Let's move on to the next point. So these are the three basic signals of which the energy you should always remember. The most important is triangular one. You should always remember the triangular signal. Energy. Okay, because many a times it is very difficult to calculate it mathematically. Okay, now sum of two signals. Suppose we have two signals, x1t plus x2t is equal to xt. Okay, now we have to find out the energy of xt. Energy of xt will be minus infinity to infinity x1t plus x2t whole square. Okay, so this integration will be minus infinity to infinity x1 square t dt plus minus infinity to infinity x2 square t dt, and the third term is 2 times of minus infinity to infinity x1t x2t dt. Okay, so we can see that this is energy of x1, this is energy of x2, and the third term is 2 times of minus infinity to infinity x1t dt. Okay. So this is of energy of x. So we can see that the energy of sum of two signals, the energy of sum of two signals is not equal to energy of x1 plus energy of x2. No. There is one more term, that is third term, 2 times of minus infinity to infinity x1t dot x2t. Okay. Always remember this. So it can be asked in any statement wise format, statement wise question. Okay. So what is orthogonal signal? So always remember, this is also a very important definition of signals, that is what is orthogonal signals. What is orthogonal signals? So if we have two signals x1t and x2t, x1t and x2t, they are orthogonal if they are orthogonal if minus infinity to infinity x1t multiplied by x2t dt is equal to 0. Okay. Minus infinity to infinity x1t multiplied by x2t is equal to 0 means multiply the two signals and integrate the result from minus infinity to infinity. If you are getting a 0, then the signals are orthogonal. For example, let me take an example for you. Example, suppose we have two signals. First example is very easy one. Suppose we have a signal like this, another signal is like this. So we have a signal that is from 0 to 5, and then the signal is 10 to 15. Okay. So height is 10. This is your x1t, let us say, and this signal is x2t, and the value is minus 10. Okay. Now if you multiply these two signals, we can see that when we multiply these two signals, this signal is existing from 0 to 5 only, and this is existing from 10 to 15. When we multiply these two, we'll get a 0. We'll get a 0. Okay. And thus we can see that x1t multiplied by x2t integration minus infinity to infinity dt will be 0. So are these orthogonal? Are the signals orthogonal? Yes, these are orthogonal. Okay, these are orthogonal. Always remember that these signals are orthogonal signals. Okay. Now one more point here, one more very important point, that is if the two signals are orthogonal, if we come back to this slide, we can see that if x1 and x2 are orthogonal, then this third term will be 0. Then the third term will be 0. We can write that energy of x is equal to energy of x1 plus energy of x2. Okay. Great. So if x1 and x2 are orthogonal, then energy of x will be equal to energy of x1 plus energy of x2. Okay. So in that case, energy of x will be equal to energy of x1 plus energy of x2. Okay. Now let's move on to this case. Suppose this is an example and you have to find out the energy of this signal. Okay. Now we can see that this whole signal x, suppose this is x, this whole signal x can be written as sum of two signals. Okay. We can write this as a sum of two signals. We can write it as a sum of two signals. The first signal is a triangle from 0 to 10. Okay. And another one is a rectangle from 10 to 20, 10 to 20, 0 to 10 and 10 to 20. Height is 10 and here height is minus 10. Okay, so this is your x1 and this is your x2. So can we write x is equal to x1 plus x2? Yes, we can write x is equal to x1 plus x2, right? Yes. Are these x1, x2 orthogonal? Yes, that is also true, because if we multiply x1 with x2, then we will get a 0. And thus, when we will get a 0, thus these are orthogonal. So we can say that energy of x is equal to energy of x1 plus energy of x2. Now, energy of this triangle, we know the formula, that is height square multiplied by width divided by 3, plus energy of this rectangle is height square, that is minus 10 square is only 10 square multiplied by width. So this will come out to be 1000 divided by 3 plus 1000. So the answer is 4000 by 3. I hope all of you are able to do this. Okay, so this is a method by which we can solve many questions very easily. Okay. Second is, we have to find out the energy of this signal. Okay. Now the energy of this signal, we can see that this whole signal x, can be written as the sum of two signals. One signal is rectangle. Of height 10, from 0 to the width is, let us say, 20. 0 to 20, height is 10. This is your x2, and x1 is x1 is 0 to 20. Height, what is the height of this rectangle? Rectangle height is 10. The triangle height is 10 only. Okay, we can see that. We will break it into two parts. Rectangle and triangle. So we can see that the triangle height is 10 again. Now we can see that this is x1, this is x2. They are not orthogonal. They are not orthogonal, right? They are not orthogonal. This is x1, this is x2. Now we can see that energy of x is equal to energy of x1 plus energy of x2 plus 2 times of minus infinity to infinity x1 x2 integration. Okay. Now let us multiply x1 x2. Let us multiply these two x1 x2. Let us multiply. Let us multiply these two. So when we multiply the triangle and rectangle, we will get a triangle only. Only difference is the height of the triangle will change. Okay. Let us see. If you multiply this rectangle with this triangle, so means the triangle is getting multiplied by 10 directly. So we can see that the height of the triangle will be 0 to, the width is 0 to 20, height is 100. Okay, height is 100. Now, so this is your x1, x2. Okay, so we can see that x1 multiplied by x2 minus infinity to infinity dt. What will be the result? The integration of this, what will be the result? That is half base into height, 100. That is 1000. Okay. So we have this integration also. Now energy of x1. Energy of x1 means energy of the triangle. What is the energy of triangle? Height square multiplied by width divided by 3. Energy of x2 means energy of this. What is the energy of this? Height square multiplied by 20. And third term is 2 times of 1000. So this is what the result is. So in these type of questions, just break it into two parts to make it easier. We break it into two parts, rectangle and triangle, and we write the energy of x is equals to energy of x1 plus energy of x2 plus 2 times of integration of this. So energy of x1 is height square multiplied by width divided by 3. Energy of x2 is height square multiplied by width, and the third term is 2 times of 1000, that is the integration of this multiplied by 2. So if we solve this, we will get, this is 2000 by 3, this is 2000, this is 2000. So if we solve this, we will get 4000 plus this, that is 14,000 by 3. Okay, great. So this is the result that we will get. Okay, now how the time shifting and scaling affects the energy. How time shifting and scaling affects the energy. So always remember that shifting does not affect the energy. Shifting does not affect the energy. Shifting does not affect the energy. Always remember that shifting does not affect the energy, but time scaling does. Okay. If we contract any signal, so let us take an example for showing it. Suppose we have a rectangular signal. Minus tau to tau, height is a. So what is the energy of this? The energy is a square multiplied by width. Okay, a square into 2 tau. So if we have one more signal, if we contract it by 2, let us say, if we contract it by 2, so let us say this is xt, and I contract the signal by 2, x of 2t, I contract the signal by 2, so it will compress. Okay, so it will get compressed. So it will be from minus tau by 2 to tau by 2, height is a again. So what will be the energy of this signal? The energy of this contracted signal will be height square, that is a square, multiplied by width. Width is tau. So we can see that if we compress the signal by 2, the energy reduces by 2 factor. Okay. So I am writing a conclusion. Suppose xt has energy E. If we multiply the signal by a constant A, then energy will get multiplied by A square. Okay, energy will get multiplied by A square. Okay. If we shift the signal, then shifting does not affect the energy. If we contract the signal x of 80, then energy will become E divided by mod A. Okay, E divided by mod A. Shifting and time reversal. If we reverse the signal or shift the signal, it does not affect the energy. Always remember that x of minus t will have same energy as E. Okay. Remember that xt has energy E. If we multiply xt by a constant, the energy will become a square times. If we shift, the energy remains the same. If we do the time scaling, energy get divided by mod A. If we do time reversal, energy does not change. So this is the question for reference. If xt has energy 24, x of t plus 10, shifting does not affect scaling, we are contracting, so it will be 24 by 2, that is 12. We are contracting again, but we are multiplying the signal by 5. So due to 5, it will get multiplied by 25. But due to compression by 3, it will get divided by 3. So this will be 25 into 8, that is 200. In the last term, we have multiplication multiplied by 10. So the energy will get multiplied by 10 square, 100. multiplied by 24, but due to compression it will get divided by 4. So this will be 600. Okay. So this is all for energy and energy signals. So power signals is left, and neither energy nor power will continue in the next session. Okay. So thank you.